Okay, so in part 1b of inequalities, we're going to continue solving linear inequalities. Let's go ahead and solve each inequality. Number one, suppose we had 3x plus 2 divided by 6 minus 1 is less than x divided by 3. All right, so I want to solve this inequality. Now remember, just like in the previous lesson when we had those fractions, you got to find the LCD. So we want to clear the denominators, we want to clear the fractions. So the LCD in this case of 6, and remember this is 1 over 1, or negative 1 over 1. So 6, 1, and 3 would be 6. So we're going to multiply both sides by 6. Now since this right here, technically you see these two terms, one term and another term. Here there's only one. So we're going to put parentheses around this one. So you're going to say 3x plus 2 divided by 6 minus 1, close parentheses, is less than x divided by 3. And the reason we're going to put parentheses here is because every term on this left side has to be multiplied by 6. So you have to distribute the 6. And over here, what I do to one side, I have to do to the other. All right, so the next step is to distribute the 6. And so you're going to have 6 times this fraction. So you're going to say 6 times 3x plus 2 divided by 6 minus, and then 6 times 1 is less than 6 times x divided by 3. So all I did was I multiplied every term by 6. So notice this is multiplied by 6, this is multiplied by 6, and this is multiplied by 6. So every term has to be multiplied by 6. So if multiplied by the LCD, those denominators right here will become 1s. And so you'll say 6 into 6 is 1, 6 into 6 is 1. Now, be a little bit careful here. If this was something other than 1, you would have to distribute this. So you may want to, if you do have some situation like this, put this numerator in parentheses, because if this was, let's say, a 12, you would have to distribute the 2. If this was an 18, let's say, you'd have to distribute a 3. So 3x plus the 2 has to be multiplied by this number. But that's just 1. So the parentheses wasn't needed here, but it was something else other than 1, you need the parentheses. So you can use the distributive property. So I'm going to go ahead and leave it there, and then I just want you to notice, so you're going to multiply everything in here by this 1. So 1 times 3x plus 2 is 3x plus 2. So that's what goes here. Minus 6 times 1 is 6, negative 6. Less than, over here, when you reduce, 3 into 3 is 1, 3 into 6 is 2, you get 2x. Alright, so I'm going to go ahead and combine like terms. Now you need to be a little bit careful. I've seen some people do this. They'll say minus 2 minus 2. You can't do that. You can't say subtract 2 and subtract 2 on the same side. What you do to one side, you have to do to the other. So when you get to this point, you need to actually tell yourself, I am combining a 2 and a negative 6. That's what I'm combining. And a 2 and a negative 6 is a negative 4. So this becomes 3x minus 4. All right, so be careful. There's quite a few students that will say subtract 2 here. And then say this is a negative 8. And it's not a negative 8. You see it's a negative 4. Okay, so that is a mistake I've seen in the past in a previous course. So don't make that mistake in this course. It's less than 2x. And so if I subtract 2x from both sides, just go ahead and bring the variables to the left. If I subtract 2x, I get 3x minus 2x is x, minus 4. It's less than. Now if you do that, there's something that goes there, a number goes there, and you know that number has to be 0 because 2x minus 2x is 0. And now if I add 4 to both sides and combine like terms, I get x is less than 4. All right, so your solutions would be any number less than 4. So your graph would look like this. So this is 0, and this is 4. You'd have parentheses on 4, and then shade to the left. And then your interval notation, remember, go from smallest to largest. So you're pointing towards the concept of negative infinity here. So your interval notation would be negative infinity to 4 with parentheses. Now remember, negative infinity and infinity, you're always going to use parentheses. And the only reason why I'm using parentheses with this 4 here is because there's no equal sign, so which means that I can't include a 4. 4 is not a solution, but anything up to 4, like 3.999, 3.9999999, and so on, is a solution. All right, so there's your graph, and there's your interval notation. This is the interval notation. So remember, there's an infinite number of solutions. There's an infinite number of solutions. You cannot count them. There's not a finite number. There's an infinite number. Okay, number 2. All right, suppose you had... Number 2, let's say we had this. Let's say we had x minus 4 divided by 6 is greater than or equal to x minus 2 divided by 9 plus 5/18. Plus 5/18. All right, so remember, I have fractions, so I want to clear these denominators. I want to clear these fractions. So I got to find the LCD. So the LCD of 6, 9, and 18 is 18. So I'm going to multiply both sides by 18. Now, if you notice, there's only one fraction here, so I'm not going to use parentheses, but I have 2 here. So I'm going to put this inside parentheses. So I'm going to say x minus 4 divided by 6 is greater than or equal to, and then x minus 2 divided by 9 plus 5 divided by 18. And so I'm going to put this in parentheses right here, and then I'm going to multiply both sides by this 18. So what I do to the right, what I do to the left, I do to the right. All right, remember, the whole purpose of multiplying by the LCD is to clear these denominators. So you'll notice that at some point, just like in the previous one, at some point my denominators became a 1. See this? That's what you need. So you got to, and then the next step, you no longer have these fractions. All right, now remember what we talked about here. Remember this right here, where we put parentheses in the numerator? Here's the situation again. So here, when I reduce 6 into 6 is 1, 6 and 18 is 3. If you're not careful, you're going to say 3x minus 4, and this is not 3x minus 4. So it's not 3x minus 4. So you need to put this in parentheses and then distribute the 3, because what it is this. It is 3x minus, and then 3 times 4 is 12. It's 3x minus 12. So be careful. Put that in parentheses if you need to. If the numerator is more than one term, put it in parentheses. Okay, it's greater than or equal to, and then we're going to distribute the 18. So actually say 18 times x minus 2 over 9 plus 18 times 5 over 18. So right in that step. So notice every term was multiplied by 18. This term by 18, this term by 18, this term by 18. And now reduce. 9 is 1, 9 to 18 is 2, and notice that if I'm not careful, I'm going to say this is 2x minus 2, and it's not. You know now it is not. When you distribute, this really becomes 2x minus 4. And then over here, when you reduce, you just get a 5. So I get this now. I get 3x minus 12 is greater than or equal to, all right, when I distribute, that's going to be 2x minus 4, and then plus, and then that's just going to be a 5. Combining like terms. Now remember, you're not going to say plus 4 plus 4. That's become a mistake. And say this is 9. This is not 9. A negative 4 and a positive 5 is 1, a positive 1. So you get 3x minus 12 is greater than or equal to 2x plus 1. Now bringing, so again, we went from a linear inequality that had fractions to a linear inequality without fractions. So that was the whole point. So remember, in place of these denominators, you want to get 1s at some point. Okay, subtracting 2x from both sides. 3x minus 2x is x, minus 12 is greater than or equal to, and they combine like terms at 0, you're left with 1. Adding 12 to both sides. Combining like terms. Negative 12 and a positive 12 is 0, so your solutions are any number that's bigger than or equal to 13. So your graph, and this is 0 and this is 13, let's say, you use brackets going to the right. And then your interval notation, and we go from smallest to largest. So my smallest is 13 with a bracket, all the way to infinity. And remember, with infinity to negative infinity, we always use parentheses. All right, number 3. All right, suppose we had 4 times 3x minus 2 minus 3x is less than 3 times 1 plus 3x minus 7. All right. So notice I have some parentheses here, so I'm going to use a distributive property. So I'm going to distribute the 4 here, and I'm going to distribute the 3 here. So I get 4 times 3x is 12x. 4 times a negative 2 is a negative 8. Minus 3x is less than 3 times 1 is 3, and then 3 times 3x is 9x minus 7. Combining like terms, a 12x and a negative 3x is a negative 9x minus 8. It's less than. And then here, I get 9x, and then a positive 3 and a negative 7 is a negative 4. And notice what's going to happen when I bring the variables to the left. Watch what happens. And you talked about this in a previous course. Negative 9x, 9x minus 9x, those cancel out. That's 0, and you're left with negative 8. It's less than 9x minus 9x, that's 0, and you're left with negative 4. And so you asked yourself, see, there's no variable there. In all the other problems, you had a variable in your final statement. Now, when the variable disappears, remember what happens. When the variable disappears, you got to look at your statement. So either, if the variable disappears, either your solution is going to be all real numbers or your solutions are going to be no solution. So if the variable disappears, if the variable no longer exists, you need to look at your statement. Look at your statement. Your answer will be no solution. And remember, sometimes in your book you're going to use the empty set. This is the empty set. Or it will be all real numbers. All real numbers. And as an interval notation, remember to look like this, negative infinity to infinity. So if you look at the statement, you got to look at the statement and ask yourself, is that a true or false statement? So is negative 8 less than negative 4? So you look at the number line. If you look at the number line, here's negative 4, here's negative 8, and as you go to the left, it becomes smaller. So yes, that's a true statement. So that's a true statement. So you ended up with a true statement. So what that means is that no matter what I plug into x, this side's always going to equal that side. No matter what number I plug in, any real number was going to work. And so what that means then is that your solution is going to be all real numbers. So your graph will look like this. So if you ask to graph it, you're going to shade everything. Everything is shaded. Everything is shaded. In interval notation, remember, we always go from smallest to largest. Well, if everything is shaded, you go from negative infinity all the way to positive infinity. And that's the graph. So remember, if it's a true statement, it's going to be all real numbers. So you're going to graph the whole number line, and it's going to be the intervals will be negative infinity to positive infinity. So all real numbers is the solution. So remember, this means all real numbers. All real numbers is a solution. Okay? All right, now, if, let's suppose we had this. Suppose we had this, number 4. Suppose we had 5 times x minus 2 minus 3 times x plus 4 is greater than or equal to 2x minus 20. All right, suppose we had that. So let's see what happens. So if I distribute in both cases, This one's easy. That's going to be 5x and then minus 10. Now be careful. Go ahead and distribute the negative 3 here. Distribute the negative 3. So distribute the negative 3, and negative 3 times x is negative 3x, and negative 3 times positive 4 is a negative 12, and that's greater than equal to 2x minus 20. Combining like terms, 5x and a negative 3x is a 2x. A negative 10 and a negative 12 is a negative 22. And that's greater than equal to 2x minus 20. Now look what happens when I subtract 2x, just like what happened here. When I subtracted 9x, I ended up with a statement that no longer had a variable. So I had to determine whether it was a true or false statement. That statement's true, so that means that my solutions are all real numbers. No matter what I plug into x, the variable x, this statement will always be less than that statement. So over here, if I subtract 2x from both sides, 2x minus 2x is 0. You're left with negative 22. That's greater than or equal to, and then negative 20. And so you got to ask yourself, is this a true or false statement? My variable no longer is there. But if you look at this, a negative 22 on the number line, here's negative 22, here's negative 20. A negative 22 is not bigger than a negative 20. A negative 22 is actually smaller than a negative 20. So this is a false statement. So what that means is that there's going to be no solution. So your solution on the math lab, if I put the blank here, you're going to say the empty set, or you say no solution. Remember, the empty set means no solution here. And then if there's a graph, you wouldn't graph anything. Leave it blank. Leave the graph blank, because there are no solutions. Because there are no solutions. All right, so nothing, no matter what number you plug into the original, nothing's going to work. All right, so I just want to show you something. We're just going to check 2 of them. So remember in number 3, we said the solutions was all real numbers. So let's just check x equal 5. Let's see if 5 works. So go back to the original. So we'll go ahead and write the original over. Here's the original, and let's see if it works. It's supposed to, because we said it's all real numbers. So where we see the variable x, I plug in 5. So here I get 4 times 3 times 5 minus 2 minus 3 times 5. And I want to see if that's going to be less than 3 times 1 plus 3 times 5 minus 7. So using the order of operations, we do the parentheses first. 3 times 5 is 15. 15 minus 2, that's 15. 15 minus 2 is 13. And that's 15. And we see that's less than. This is 15. 1 plus 15 is 16 minus 7. Right, so 3 times 5 is 15. 15 plus 1 is 16. Now use your calculator. 4 times 13 is 52. And 52 minus 15 is 37. So that's 37. So the question is that going to be less than 3 times 16 is 48 minus 7, which is 41. So is 37 less than 41? The answer is yes. So 5 is a solution. And if you do this for all of them, for any number, decimals, fractions, negative numbers, positive numbers, 0, this side will always be less than that side. So that number you eventually end up with will be less than that number. Now number 4, this was for number 3. In number 4, if you check, let's say x equal 5 again. So remember in number 4 we said there weren't any solutions with the empty set. All right, so let's see why that's the empty set. So here is my original. The original. So this was the original. All right, so let's see why that didn't work. So when I plug in 5, I get 5 times 5 minus 2 minus 3 times 5 plus 9 is greater than or equal to 2 times 5 minus 20. So I want to see if if this side is going to be greater than that side or equal to that side. So 5 minus 2 is 3, so I get 5 times 3, which is 15, minus 3 times 9 plus 5 is 14, and then 3 times 14 is 42, and I want to see if that's going to be bigger than or equal to, 2 times 5 is 10, minus 20, so is that bigger than or equal to, and then 10 minus 20 is a negative 10. 15 minus 42 is a negative 27, so the question becomes this: is a negative 27 bigger than or equal to a negative 10? And the answer is no. All right, so that was a question. So no matter what number you plug into this equation, this inequality rather, the left side, whatever you get here, will never be bigger than or equal to the right side. All right, so just a reminder, and you had this last semester, whenever the variable disappears, either you're going to get no solution or you're going to get all real numbers. If it's a true statement, it's all real numbers. And your graph, for the graph, you're going to shade in the whole number line. If the variable disappears, then you get a false statement, so that's not a true statement. Negative 22 is not bigger than or equal to negative 20. Then you're going to say no solution, or use the empty set symbol. And if the graph is there, you're going to leave it blank. Leave the graph blank because there aren't any solutions. Okay, so that's going to take care of part 1b. So part 1b, we talked about solving inequalities with fractions, and we also discussed, well, what happens when the variable disappears. You're going to end up with either no solution or all real numbers, and that's based on your statement, whether it's true or false. Okay, so that takes care of that one.